Recall that factoring is just another way to rewrite in like a condensed form what multiplies to give you a positive 42 and combines to give you a positive 23. So I'm going to go 42 divided by 1 divides it evenly, but it doesn't give you 23. 42 divided by 2. What's 42 divided by 2? What's 42 divided by 2, kiddos? 21. So 21 times 2 is 42. Do these add up to 23? Yes. Now the signs do matter. They both have to be positive. Same sign and both positive. Whenever the leading coefficient is anything other than 1, I'm going to choose to do it what I think is the efficient way. So x plus 2 and x plus 21. But here's what a lot of people forget. I think this is the more efficient way. You could do the AC plus B method. That's no problem. I like to just throw this number underneath. That's my method. You don't have to do that. And then I reduce this down, and I'm going to show you how I do it. And then I'll show you how most of you prefer. Divide by 3 is 7, divide by 3 is 2. And then I do a bottoms up. So I get 3x plus 1 and 2x plus 7. That's how I choose to do it. But as I showed you at the beginning of the year, and we took a vote, this is how most of you prefer to do it, and you did very well with it. This is the AC plus B method. I take the two numbers that I selected, I put them down in between, and now I go ahead, what can I factor out? I can factor out a 2x. I'm left with 3x plus 1. I rewrite the 3x plus 1. What times 3x is 21x, a positive 7, and 7 times 1 is 7. They both contain a 3x plus 1. In front of the first is 2x, in front of the back is a positive 7. Whether you do it the shortcut method like I use, or you prefer the AC plus B method, we get the exact same answer, and they're an alternative way to write this original expression. Expression number 2. 9 breaks into 3 times 3, 49 breaks into 7 times 7, 8 breaks into 4 and 4 evenly, and 12 breaks evenly into 6 and 6. I have to have subtraction to keep going. In the front, I have a 3x to the 4th. In the back, I have a 7y to the 6th. One of the parentheses must have addition, the other one subtraction, and the order doesn't matter. So, for instance, number 3. If there's anything in front that I can factor out, I want to do that. So I'm going to factor out a negative 3. And now let's see what would go behind. Negative 3 times 1 is negative 3, but I need an x squared. Negative 3 times negative 4 is a positive 12. This breaks into 1 and 1, 2 and 2. X squared breaks into x to the first and x to the first, and I have subtraction. So these first two parentheses, the 1, x to the first, 1x to the first goes in the front. You don't need to put to the first here if you don't want to. 2 is going back, 1 is positive, and 1 is negative. And this is where most students stop and they make a mistake. What did I forget to bring down? The negative. Whenever you have 4 terms, we're going to always look to see, can I factor by grouping? What is the largest numerical value I can factor out? Yes, I can factor out 2, but even larger. I can factor out a 4. And out of these two terms, I can take out an x squared. 4 times 1 is 4. I need 3 x's, but I only have 2. 4 times 2 is 8. I need 2 x's, and I already have them. I'm going to take what's in parentheses. I'm going to copy and paste it in back and ask myself now, what times 1x squared? What value times 1x squared would give you a negative x? The answer is negative 1. Negative 1 times 1x is negative 1x. And negative 1 times 2 is a negative 2. So this is all good. In the front and the back, we both have a 1x plus 2. In front of the first part is a 4x squared. In front of the back is a negative 1. If you stop now, though, it'd be wrong. Turn to your partner. Which parenthesis can I go further with? Talk to your partner. Which parenthesis can I go further with? Two x's go in the front, one's in the back, one's positive, one's negative, and don't forget to bring down the 1x plus 2. This would be my final factored form. This is equivalent, it's just rewritten, equivalent to the original expression. Go ahead and factor. Cannot factor. Let's try another one. What about this one? Cannot factor. Okay? Can't have that addition sign. Okay? Remember, I gave you that little cheat sheet? You're welcome to look at it. Look at the cubes. What is 8 equivalent to? What times what times what? 2 times 2 times 2. What is 1 equivalent to? Now, when we're doing the sum or difference, so this could be addition or subtraction. This could be addition or subtraction with cubes. There's always going to be 2 terms in the first parenthesis and 3 terms in the second. This is always going to be positive no matter what problem we're doing. So I take out one of the first two, so a 2 and an x. I bring down the symbol and one of the ones. Now in the front, I take the remaining front. 2 times 2 is 4. X times x is x squared. And the very back, 1 times 1 is 1. How do I determine this symbol, whether it's positive or negative? Turn to your partner. How do you determine? It's always opposite of the initial. So this was positive, this becomes negative. Now, how do I determine this term? So we know the symbol, but how do I determine it? You multiply these two. 2x times 1 is 2x. How do we factor this expression? $25 breaks into 5 and 5. 49 breaks into 7 and 7. 5, 5, and 7, 7. So it is a 25. So I have 5 in front, x to the 5th in front, and back I have 7 and y to the 7. 1 is addition and 1 is subtraction. All right, so let's take a look at this. 6 times negative 1 is negative 6, combined to give you negative 1. Okay, 1 and 6, that doesn't work. 2 and 3, 2 and 3 would work. Now, how do I decide what's positive and what's negative? So the larger of the two numbers is going to be negative. And this works, multiplies and combines. So I'm going to use the AC plus B method since the majority of students prefer that method. I'm bringing down a positive 2x and a negative 3x. I can factor out a 2x to get 3x plus 1. And let's make sure I did the math right. Multiplies. I copy down 3x plus 1. What times 3x is a negative 3x? I get negative 1. And negative 1 times 1 is negative 1. Now, they both contain a 3x plus 1, and from the first part is a 2x, and from the back is a negative 1. This will be my final factored expression.